Namaste everyone and welcome to the second session in this fantastic series titled Algebra for CAT, where the expectation is to pick up certain question types, understand the approach to solve them, and then practice questions from previous year's papers. So stay till the end of this session where we are going to solve 5 questions from some of the previous year's papers based on just one single concept. So without wasting any more time, let's jump right in towards that particular concept. So as far as this session is concerned, the focus will be on this particular variety of questions based on algebraic equations or expressions calculating positive integer solutions or distinct integer solutions. So the standard variety that you might come across for such sessions will be based on the general expression of this form. There will be a base and it will be raised to a certain power. At the right hand side would be given to equal to 1. So understand, whenever you are given, let's say, a quadratic expression here in the base, again a quadratic expression in the power, and then this is equal to 1, and you are asked either the integer solutions or positive integer solutions and so on. So how to approach this particular variety of questions? Understand that whenever you have an expression in base raised to a certain power, to get the final answer equal to 1, there could be 3 possible cases. So let me write down the first case, and you have to remember them as it is, because otherwise you might make mistake in calculating the number of solutions. So case 1 is when the base is equal to 1, then you don't need to worry about anything else about power. If the base is 1, 1 raised to anything will be equal to 1. So pretty straightforward. Second case that we need to remember while solving this is the base could also be minus 1. But if the base is minus 1, what should be the power raised to minus 1 so that it becomes equal to 1? So we'll say power has to be even. So understand that power has to be then equal to an even number. Now negative values are also acceptable. For example, we get minus 1 here, and minus 1 raised to the power minus 2 can be written as 1 upon minus 1 raised to the power 2, which will be 1 upon 1, again equal to 1. So when you say power even, also consider negative integral values for the same. And the last case that we could possibly have is that base is not equal to 0. So that is there, and the power is equal to 0. So remember, b raised to the power 0, any number raised to the power 0 will be equal to 1. So these are essentially the 3 conditions that we need to remember. And just for the sake of everyone, we should be on the same page. Understand that positive integer solutions would be natural numbers. Put this in your head. Positive integers would be natural numbers. So you have 1, 2, 3, 4 and so on till infinity. Same as natural numbers, same as positive integers. When they say non-negative integers, we include a 0 as well. So whole numbers is same as non-negative integers. And the third part is when you say solutions versus integer solutions. So when you say solutions, it includes all kind of solutions, whether integers or fractions, doesn't matter. But when they say integer solutions, it has to be an integer. So these are few cautions that we need to keep in mind, and you will find some very interesting variations in question types that test our ability to understand and be very careful while solving these questions. So very interesting set of questions at the end. Finally, so this is one part. Make sure that you've made a note of it, and we'll see how the application part goes in some of the questions. The second part that we need to take care of is with regards to understanding the concept of modulus. So a lot of questions of this type where number of integral solution are asked deal with a modulus of x. Now understand, if modulus of x is given as 5, then there are 2 possible values of x that justify this answer, 5 as well as minus 5. So one, understand that if modulus of x is given to be equal to some positive number, and it has to be a non-negative number only, modulus of x can never be given as negative. So the output for LHS has to be positive. It is given to be a positive number or a 0. So 5 and minus 5, 2 possible solutions are available. Also remember that if in such a case you are given modulus of x as, let's say, equal to fraction 1 by 2, then again we'll get 2 solutions, 1 by 2 and let's say minus 1 by 2. But just be very careful, the moment question says integral solutions, so then 1 by 2 minus 1 by 2 are not integral. 5 minus 5 both are integral solutions. So question says number of integer solutions, include both of them, don't exclude these. So this is something that we need to remember. The second part is if modulus of x is equal to any number, let's say is equal to p. So if modulus of x is p, then if I do whole square, I can always say x square is equal to p square. So remember this, wherever will be required to make use of replacing modulus of x, we can replace it with another variable p so that we don't have to really deal with modulus, and then we can square so that squares can be used in normal operations. That is one important part that we can take into account. The next part that is important while solving questions of this type is making sure that whenever you get an expression of the form where left hand side is given equal to right hand side, and a lot of aspirants tend to commit this common mistake, which is if the expression is, let's say, something like x into x square plus 5x plus 7 is equal to, let's say, x cube. A lot of times while solving, people tend to do this, that they will cancel this x with x and then straight away start simplifying. X square plus 5x plus 7 is equal to x square. So you can cancel x square and then you get your answer as x equal to minus 7 by 5. Sir, this is the answer. Now you have made a lot of haste in solving. Nothing wrong in cancelling. But essentially when you are cancelling, you are also admitting subconsciously to this fact that x equal to 0 is also a possible solution. So understand the technically correct approach for this would have been, this is x into x square plus 5x plus 7 minus, if this was x cube, on the right hand side it will come out to be minus of x cube equal to 0. From these two terms you are supposed to take x common, and then the inside bracket would look like x square plus 5x plus 7 minus x square, this equal to 0. So effectively you have product of two possibilities getting equal to 0. So either the first possibility will be equal to 0 or the second possibility will be equal to 0, which is giving us this result of minus 7 by 5, which means there are two possible solutions for this, x equal to 0 or x equal to minus 7 by 5. So always remember this, and CAT is known to test you on these silly mistakes, if I can call them, but then every mistake is as grave a mistake as any other mistake, because it is eventually going to cost you either 3 marks or 4 marks depending on the negative marking. So understand that never cancel directly. Whenever you are cancelling, admit to yourself, there is a solution x equal to 0 possible as well, or do this longer way where you take common. My suggestion is keep this at the back of your head. The moment you are cancelling, x equal to 0 is also a solution. So if this is something that you are keeping in mind, then let's jump straight away to solving few questions from the CAT previous year's papers. So here we have a question from CAT 2020 slot 1, and again this series will dispel all such notions that you might have that CAT has a very difficult pattern in quant where no questions get repeated. I am of the opinion that almost every year you'll find at least 3, 4, 5, 6 question types getting repeated in every slot. So this is from CAT 2020 slot 1. You have an expression which is base raised to some power equal to 1. We are going to spend some time understanding the detailed solution, but for the next set of questions we are going to move fast. And once you've seen the solution for this, I'll expect that you move really fast to solve questions on your own by pausing the video from next question onwards. Also, if possible, please share the amount of time that you typically take to solve such questions. My suggestion will be it should be under 2 minutes, maybe under 1.5 minutes. The less it is, the better it is for you, because I will categorize this as standard question types. The next time you see such a question, you should be like, okay, let me jump right in and get the answer as quickly as possible. So we'll create the 3 possible cases that we had talked of. We'll start with case number 1. So I'm just going to write C1. So we have base is equal to 1. So if I take base as 1, can I say this expression x square minus 7x plus 11, which is our base in this scenario, will be equal to 1. If I take this to the left hand side, it becomes x square minus 7x plus 10 is equal to 0. Now you should be very comfortable with solving quadratic. You can just split the middle term 5 and 2 and you are getting 10. So it's very easy to observe that the two corresponding values here could be 2 and 5. When the base is 1, we don't really need to check anything else, which means these two are definitely a part of our answer. So minimum 2 option is also there, not really helping, but 2 and 5, 2 positive integral values are available for us. Second case that we are going to take is when base is minus 1. Remember, when base is minus 1, we just have to check whether the power is even or not. So let's do this. Base is minus 1. So you can have x square minus 7x plus 11 is equal to minus 1. When you simplify, this becomes x square minus 7x plus 12 is equal to 0. Again, you can split the middle term to get a product of 12. You will get 2 possible answers. 3 and 4. Just put the value of x equal to 3 or 4 in this expression for par. So if you have 3 square 9 and 13 3s are 39. 9 minus 39 minus 30 plus 42. This is an even value. The other way easily could be to just put 3 and 4 in this expression and check for the parity, whether it is even or odd. So this is our expression for par, and what we are doing is just putting x equal to 3. 3 is an odd number. So if this is odd, if x is odd, this will be odd minus 13. An odd number into odd will be odd, plus we have an even number. So odd minus odd is even, even plus even is even. So for an odd number it is valid. If it is even, if x is even, then even square will be even minus even will be even, plus even will also be even. So again it is coming out to be even, which means these two are also acceptable solutions. So 2 and 2, 4 solutions are already there. Then there is another third case that we have to take care into account, which is the par being equal to 0, where the base is not equal to 0. So if par is equal to 0, which means this expression x square minus 13x plus 42 is supposed to be 0. So we'll again split the middle term so that the product is 42. 7 6 are 42. So clearly the two corresponding values are 6 and 7. For this, is the base coming out to be 0? Not really, because we can observe if we put 6 or 7, this value 6 square 36 minus 36, 7 6 are 42 minus 6 plus 11, positive number. Same you can justify for the value of 7, which means 6 7 3 4 and 2 5. These are the 6 possible positive integral solutions. Correct answer is choice 1. Now understand that you could be given a question in this year's CAT or next year's CAT where the term distinct plays a role. In this case, 6 7 3 4 2 5, nothing had there was no number, no solution in common. But imagine the answer here possibly came out to be 2 4. Then 2 would have been a common solution, so you will not count 2 twice. So CAT is known to test you on these small little things. Make sure that you don't make haste while doing this. Otherwise, it's a very straightforward way. 3 cases, base being 1, base being minus 1, and the par being equal to 0. Just keep this in your head and you'll be in a great position to solve these questions with ease. For the next question now, so let's move ahead to the next question. For the next question, I'll expect you to pause this video, solve this question on your own, and tell me the time that you took in the comment section. Let's jump right in. Number of integers. So the important keyword here is integers that satisfy the inequality x square minus 5x plus 7. I'll straight away start with the case 1, which is base is equal to 1. So I'm not even going to write all of that stuff. I know in my head there are 3 cases. So this becomes equal to 1. So if this is equal to 1, it becomes x square minus 5x plus 6 equal to 0. I can get x equal to 2, 3. These are the possible values for x given base is equal to 1. Second scenario, when base is equal to minus 1, so I'll have x square minus 5x plus 7 is equal to minus 1. So when you simplify, this becomes x square minus 5x plus 8 is equal to 0. You can try and simplify this. Are you getting some integer solutions? Just take the discriminant. Discriminant is b square minus 4ac. This is 32. So we're getting imaginary values here. So we're not going to get integers that are going to satisfy this equation. So we've taken the 2 cases very quickly. Let's move to third case, which is the par being equal to x plus 1 being equal to 0. So we get x equal to minus 1. So when par is 0, if you put x as minus 1, this becomes 1, this becomes 5. So 5 and 1, 6 plus 7, this is not 0. So which means, is minus 1 an integer? Yes. So this is an acceptable solution. 2 and 3 are also acceptable solution. So 1, 2, 3, overall 3 solutions. Correct answer is option 3. I hope this is now seeming to be easy. Now understand, there was a question earlier in CAT 20. This is again a question from CAT 20 slot 2. CAT 20, remember, was conducted by IIM Indore. This year's CAT is expected to be conducted by IIM Indore. No conclusions to be drawn. Let's move ahead to the next question. Again, CAT 22 slot 2. Same question type. Let's move ahead quickly and create the 3 cases. Base is equal to 1. So x square minus 10 is equal to 1. So we get x square is equal to 11. Are they asking integer solutions? So we get x equal to root 11, which is clearly not an integer. The second scenario is base is equal to minus 1. So x square minus 10 is equal to minus 1. X square is equal to 9. X gives us plus 3 minus 3. Both are integer solutions, but The power has to be checked, that power has to be even. What is the power? Power is x square minus 3x minus 10. This is the power. So if I put x equal to 3, so 3 square 9, and this is minus 9, so this becomes minus 10, which is acceptable. Even negative values are also acceptable. So plus 3 is valid. If I put minus 3, this again becomes 9. This becomes 9 plus 9, 18 minus 10 plus 8. This is also acceptable. So both of them are acceptable solutions for the second case. And very quickly, the third case is simply putting the power to be equal to 0. So we have x square minus 3x minus 10 is equal to 0. Let's quickly simplify this. So we'll have x equal to 3 plus minus under root b square, which is 9 minus 4ac. So that becomes 40 divided by 2. So we have 3 plus minus under root of 49 will be 7 by 2. So we'll get two possible solutions, 3 plus 7, 4 by 2. 4 by 2 is 2, or 3 minus 7 minus 4 by 2, which is, my mistake, 3 plus 7 is 10, 10 by 2. So 10 by 2 will be 5, and 3 minus 7 minus 4 by 2, it is minus 2. So we are getting two integral solutions here, 5 or minus 2. We are getting plus 3 and minus 3, two integral solutions here. Remember, when the power is 0, we just have to check base should not be equal to 0. So x square minus 10 any which ways is only going to be 0 when it is plus minus root 10. So both of them are acceptable. These are acceptable. There are four possible solutions. So correct answer is option 2, 4. So you can understand that once you've understood a question type and the approach to solve it, and irrespective of the question type, there are always going to be three cases: base being equal to 1, base being equal to minus 1 with power minus, power being even, and the third case, power being equal to 0. The worst case that they can do is they'll have a modulus in some of the expressions in base and modulus in some of the expressions in power to make it more time consuming and complicated. But essentially the fundamentals remain the same. Let's look at the next question type now. So we have again a question number of solutions. So are they specifying integers? The first part that you should be careful about while reading a question should be this, that they are asking number of solutions, and therefore integer, non-integer does not matter. For the equation modulus of x, 6x square plus 1 is equal to 5x square. Now understand, can I cancel this mod x with x? Yes, but at the back of my head, I should know that x equal to 0 is a possible solution. So because they are saying we need to find solutions for mod x, it's a better idea to say, let's substitute mod x with equal to p, so that you will never commit an error. Because mod x equal to, let's say, 2 will give you two possible solutions, plus 2 minus 2. If you just consider it and cancel, then you will simply be dealing with x, where you will probably ignore the negative aspects of the corresponding solution. So mod x equal to p. If I do that, then I get p 6p square plus 1 is equal to 5p square. Now can I cancel p with p? Yes, at the back of my mind I should know that mod x is equal to 0 or p is equal to 0. Now let's simplify this. So I get 6p square plus 1 is equal to 5p. I get 6p square plus 1 minus 5p is equal to 0. I'll solve the quadratic. P is equal to 5 plus minus under root b square. Minus 5 square is 25 minus 4ac, that is 24 whole upon 2a, which is 12. So I get 5 plus minus, this is under root of 1 divided by 12. So I get two possible answers, 5 plus 1, 6 by 12, which is 1 by 2. 5 minus 1, 4 by 12, which is 1 by 3. So this is another possibility. Now understand, when you say p is equal to 0 is a possibility, p is equal to 1 by 2 is a possibility, and p is equal to 1 by 3 is a possibility. A lot of aspirants may commit haste and say three answers, three possible solutions. No, remember what was the value of p? P was mod x. So if mod x is equal to 0, we get just one answer, x being equal to 0. We are asked the number of solutions for this equation. So understand, x equal to 0 is an acceptable solution. If mod x is equal to 1 by 2, then we get two possible answers, 1 by 2 and minus 1 by 2. And same is the case, mod x is equal to 1 by 3, then we get two possible answers, 1 by 3 and minus 3. And therefore effectively 2 and 2, 4 and 1, 5. The correct answer for this question is 5. This was a question in CAT 2019 slot 1. RH is 5x square and then some expression with modulus on left hand side. I hope you have understood the approach to solve such a question. Now I'm going to throw one more question, and this will be the last question of this session. Again, I'll want you to pause the video, try and solve the question on your own. Share the amount of seconds that you are taking in the comment section to solve this, and then tell me honestly whether these sessions are helping you, are a good add-on, and what more should we come up with Any which ways, there are going to be few more sessions in the same series of algebra where we'll pick up question types and answer the questions based on the theory that we create for them. So CAT 19 slot 1 and here it is CAT 23 slot 1. 4 years later, right hand side they haven't changed 5x square. It's just that they've changed the values from 6 to 2 and some coefficients. Otherwise, exact replica of the question type, if I can use that term. Pause the video, try and get to the answer quickly. Now I'm going to move fast. I have this process inbuilt in my system, in my brain, in my blood, that I'll focus on number of integer solutions. So the previous question, we could accept 1 by 2 minus 1 by 2. Here, I will not accept 1 by 2 minus 1 by 2. I need to focus on integer solutions. Then I immediately start with assuming mod x to be equal to p. So I'll start with 2p. P square plus 1 is equal to 5p square. I'll cancel p with p and keep in mind that p is equal to 0 is one of the solutions in my head. Then I'll simplify 2p square plus 2 is equal to 5p. I get 2p square minus of 5p plus 2 is equal to 0. I'll simplify this quadratic. This becomes 5 plus minus b square minus 4ac. 4 2s are 8. This is 2ab. So this is 2 2s are 4. 4s are 16. So b square minus 4ac upon 2a. 2a will be denominator 4. So I get my answers as 5 plus minus under root of 9 is 3 by 4. So this comes out to be 5 plus 3, 8 by 4, 2, or 5 minus 3, which is 2 by 4, which is 1 by 2. So there are again possible solutions as p is equal to 2 or p is equal to 1 by 2. Now remember, p was nothing but mod x. So mod x equal to 0, mod x is equal to 2, and mod x is equal to 1 by 2. Are we asked solutions or integer solutions? We are asked integer solutions. So this is automatically rejected because we are going to get 1 by 2 minus 1 by 2. Here we'll get two positive answers, two possible answers, 2 and minus 2. And the only answers that we'll get from here is 0. So this 1, 2 and 3. Correct answer for this theta based question, CAT 23 slot 1 was 3. Again, CAT 23 was touted to be one of the toughest quant sections ever in the history of CAT paper in the entire history. From whenever CAT has existed, CAT 23 QA was the toughest, and we've been able to easily solve one question from this based on the little theory that we covered at the start. So that's it from my side. I hope you have learned something interesting and you'll be able to remember these concepts for the number of solutions based on algebra. See you there in the next session on algebra as well. That's it from my side. I'll take a leave. Ciao.